Today we're going to look at solving a nonlinear system of equations. So we're going to be working with linear equations and quadratic equations. Linear and quadratic solution sets, based on their graphs, you can have something that has two solutions, and it would look like this, where the line crosses the parabola at two different points. That would give you two solutions. You can have a line that crosses a parabola in only one point, and that would give you only one solution. And something that would have no solutions would be when the parabola and the line do not cross at all. So there would be no solution there because they do not touch. Right now we're going to look at how to solve a system of nonlinear equations algebraically. So we're going to solve them with math. We're not going to graph them yet. The steps for solving algebraically is to set the functions equal to each other, to solve the equation for x, to plug x into the linear equation, and solve. And we're going to write the answers as ordered pairs. So what we are going to do is we're going to look at this system. I have f of x equals x squared minus 6x plus 9. This is the quadratic. And the other function, g of x equals 5x, or 5 minus x, this is the linear. Okay. And just to note, f of x and g of x, these are both y. So what we can do is we can say, hey, this is our system. I have y equals x squared minus 6x plus 9, and I have y equals 5x. Now, because both of these equations are equal to y, they both equal the same thing, which means they should equal each other. So I should be able to take this and say x squared minus 6x plus 9 equals 5 minus x. 5 minus x. Sorry about that. And I should be able to solve for x. To do that, I'm going to subtract 5 from both sides. And I'm also going to add x to both sides. That will make the right side of my equation 0 because these will cancel out. And I'll have x squared minus minus 5x plus 4 equals 0. Now I can solve this in a couple different ways. I can factor, I can use the quadratic formula. It's kind of, up to you. In this case, I'm going to go ahead and factor just because I have x squared out in front, and that's probably the easiest thing to factor. So to factor, I'm going to write my two sets of parentheses. I'm going to set it equal to 0. To break apart x squared, I know that that is x times x. Then I need to look at the factors of 4 that add up to be negative 5. Now, because they're negative, I have to make sure all of my factors of 4 are also negative. These are all the factors of 4. And the only set that would add to be negative 5 would be negative 1 and negative 4. So now that I have my x values, what I'm going to do is I'm going to take both of these equations, x minus 1, and I'm going to set it equal to 0. X minus 4 equals 0. I'm going to solve for x in both cases, and I have x equals 1 and x equals 4. Now that I know what x equals, what I'm going to do is take my x values and I'm going to plug them in to my linear equation because it's the simpler equation. So when I plug in 1, I have y equals 5 minus 1. So then y would be 4. This would get me the ordered pair of 1, 4. When I plug in 4, I have y equals 5 minus 4. So y in this case is going to be 1. So my ordered pair would be 4, 1. Those would be my two solutions to this set of order, or to this system of nonlinear equations. We have a couple more examples here. I have f of x equals negative 2x minus 15, and g of x equals 2 over 5 x squared plus 2x minus 5. Now again, you can think of f of x and g of x as y. So that means I can set these equations equal to each other. And I have negative 2x minus 15 equals 2 over 5 x squared plus 2x minus 5. I'm going to go ahead and move everything over by adding 2x and adding 15. So the left side of my equation is going to be 0. On the right, I have 2/5 x squared plus 4x plus 10. And because I have that fraction, what I can do to get rid of it is I can multiply both sides of my equation by 5. It's not going to change the left side. 5 times 0 is still 0. But on the right, when I distribute, it will get rid of that fraction for me. Because 2/5 times 5, the 5's cancel and I keep that 2. So this is going to be 2x squared plus 20x plus 50. And to solve, what I can do is, first of all, simplify this. If I look at all of my numbers here, 2, 20, and 50, they're all divisible by 2. So if I divide everything by 2, I'm going to have 0 equals x squared plus 10x plus 25. And what I can do is solve this equation by factoring. X squared can be broken up as x times x. And then I need the factors of 25. That would add up to be 10, which is obviously going to be 5 and 5. So positive 5, positive 5. Now what I'm going to do is set each of these equal to 0. And because they're the same equation, they're obviously going to get me the same answer of x equals negative 5. So now that I know x equals negative 5, what I'm going to do is take it and plug it in to the linear equation. That's going to be y equals negative 2x minus 15. And I just figured out that x is negative 5. So y equals negative 2 times negative 5 minus 15. Negative 2 times negative 5 is going to be a positive 10. 10 minus 15 is going to be a negative 5. So the ordered pair for this solution set is going to be negative 5 for x and negative 5 for y. This system only has one solution. Okay, on to the last example. I have f of x equals x minus x squared, and g of x equals x plus 4. Again, because these both f of x and g of x are y, I can set these two things equal to each other. So I have x plus 4 equals x minus x squared. To solve, I'm going to subtract x from both sides and subtract 4. So I have 0 equals, x minus x is going to cancel out. So I'm left with negative x squared minus 4. And because this is difficult to factor, what I'm going to do is actually use the quadratic formula. So when we're using the quadratic formula, I know that I should have an x term. Like I have x squared here, but I should have x. Because I don't, I know that it's plus 0x, and then I have that minus 4. I'm going to label my a, b, and c values, and I'm going to plug them in to the quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So I'm going to plug everything in. I have x equals negative 0 plus or minus the square root of 0 squared minus 4 times negative 1 times negative 4 all over 2 times negative 1. So x equals positive or negative square root. Negative 4 times negative 1 is a positive 4. Positive 4 times negative 4 is negative 16 divided by negative 2. Now, the square root of negative 16, remember I can take that negative out. And the square root of negative 1 is I, so x equals positive or negative 4I divided by negative 2. Now, once you see this I, this means that our x value, our solution, is imaginary, which means that I won't get a solution for this system of equations because the system can't have an imaginary answer. So this would be a problem with no solution. Okay, and that is how you solve nonlinear systems algebraically.